trigonometric functions with periodic phenomena. The graph that you're looking at on the right side, not the circle, but on the right side of the slide, is the graph for cosine. And if we were to continue this graph, this pattern would repeat and we would see a wave. So let's take a closer look at the unit circle and see why it is that we get a wave pattern when we graph cosine. So here's the beginning of the graph, and you can see that my point right here is at 0 degrees. And what is the cosine of 0 degrees? Well, it's the x value, so it's 1. Now watch what happens as I increase this angle. Now remember that cosine is the x value. So the x value is definitely smaller where I am right now than where I started, right? Because where I started I had to go 1 to the right, and I didn't go up or down at all. And now to get to this angle I have to go, it looks like 0.743 to the right, and then up. So we're not really worried or concerned about how far up I go right now. We're just looking at this x value right here. And that's the value that's going to be graphed over here. So since I'm at 42 degrees, the point that's graphed is 0.743. Over here I'm at 42 degrees, and the amount that I have to go to the right is 0.743. So remember, I'm just plotting the x value of this point, just the x value, and that's, you can see right here. I'm going to keep opening the angle, and when I get to 90 degrees, this point, what is my x value? Well, my x value is 0, because I don't go to the right or to the left to plot this point, right? When I start at the origin, I don't go right or left, I just go straight up. So my x value is 0, which is why over here I'm now crossing the x-axis at 90 degrees. Let's keep going. Well, actually, before I keep going, what should you expect to see with the x value? As this angle opens further and further, think about what the x value is going to do. Is it going to be decreasing still, or is it going to start to increase again? Well, my x value is becoming more and more negative, right? So it's continuing its decrease until the lowest point that it's going to get is right here, -1. That's the smallest. That is the furthest to the left I can go on the unit circle. So that's going to be the smallest x value. So that means that we should see, as I continue to open the angle, that the graph is going to come back up. Because now my x value is increasing, because now I'm moving to the right. And my x value is now 0 again, and then my x value is going to continue to increase all the way back to 0, or 360 degrees, or 2 pi. Now, if I were to do this again, I would see this same pattern, right? It would just continue. It would repeat. This, what you're looking at right now, is called one period of the graph. One period is where the pattern, if continued, would then start to repeat. So it's completed a full cycle around the unit circle. So that's called one period. And we're going to take a closer look at how you figure out the period of a graph a little bit later. Okay. So now let's look at, hold on. Okay, so now let's take a look at the sine graph. The sine graph looks like this. So whereas the cosine graph started up here at 1 and it, hold on. The cosine graph started up here at 1 and it dipped down, right? The sine graph starts at 0. Now think about that and see if it makes sense to you, because here's my point. The sine graph is just graphing the y value. So what's the y value at this point? It's 0, which is why we start at 0. And then think about whether the y value would be increasing or decreasing, right, as I move around the circle. Think about it. In this part, is my y value getting larger until it reaches its maximum height, right, at 90 degrees, which you can see over here in the graph. And then I move it around more, and now I'm coming back down, right? So now my y value is getting smaller until it gets to 0, but it's going to keep getting smaller. It's going to get negative, and more negative and more negative until it reaches its lowest point on the circle, which is -1, right, at 270 degrees. And then it comes back up. So now let's take a look at this one. And here's the sine graph, and I'm going to do the same thing. Here's my starting point. We're at 0 degrees, and we're also at 0 for the y value. And now I'm going to change the angle. And you can see this time, we're not looking at this value down here like we were with cosine. This time we're looking at how far up we have to go to, or down to graph the point. So we're just looking at the y value of this point, and that's what's being graphed over here on the right. So I'm going up, up, up. This is my largest y value, right, my highest number. And then I'm coming back, my point is coming back down. And it's going to continue to go down through 0 until it reaches its lowest point at 270 degrees. And then it comes back up to 0. If I were to continue this, this pattern would continue. So again, this is called one period. This is my period length. My period length is 360 degrees, or 2 pi, because that's the amount of time it takes for this graph to complete one full cycle. All right. And that was sine. So here's a graph of cosine, and here's a graph of sine. So for cosine, we started, just to review, we started at 1, because at 0 degrees, the x value is 1. And it decreased, decreased, decreased until we got halfway around the circle to pi. And then after we hit that halfway point, now our x value started to increase, increase, increase until it got all the way back around. For our sine graph, we started at 0, and it got higher first. It went up, 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 up until it got to 1, which is its maximum height. And then on the left half of the unit circle, it's dropping, right? It's getting lower and lower and lower until it gets to its lowest point at 3 pi over 2, and then back up to 0 at 2 pi. And you can see that I've got some 1s in here and some 0s. And that's because just like graphing anything else, we have transformations that can be done to these graphs just by changing these numbers, right? So this number, if I change it, it's going to have an effect on the graph. So will this one, so will this one, and so will this one. And these are called parameters. So there are 4 parameters here. And changing each parameter is going to change the graph. So these also have variables assigned to them. And the variables for these 4 parameters go in alphabetical order. This one is called A, this one is B, this one is C, and this one is D. So we're going to look at D first. We're going to actually work backwards. So let's look at D. So I want you to look over here to the left, and you can see the graph that I'm going to plot over here on the right. Right now it's the sine curve. I guess we can leave it as the sine curve. If I wanted to graph cosine, I could just hit this little button right here, and I could turn the sine curve off. Right, but I'm going to graph the sine curve first. And I'm going to change the D slider. Now what that's going to do is, well, let me just show you. I'm going to move it just a little bit. And you can see over here in the equation, whatever my D slider is on, that number is added to the end of the equation. It does it to the other ones too, but we don't have those turned on, so we can just ignore these top two. So I'm adding 0.25 at the end of the equation. That's what my slider is telling this equation to do. But do you notice anything about the graph? Now let me go back. Here's 0. Right? And then if I increase D, what's happening to my graph? Well, you can probably see that it's going up 3, right? The midline, which is what this blue dashed line is called, the midline had started at 0 on the x-axis. And now it's up at y equals 3. So if I could keep going, it's going to go off my graph. But what if I come back down the other way? What if I make D negative? Well, then it goes down to the negative numbers. So when I subtract 1 from the end, that means that the midline is down at -1. Okay, I'm going to put this back to where it started. And now let's look at C. Tell me if you can see what C is doing. So I'm first going to increase C. I'm going to move it to the right. I'm going to move this slider to the right. So it's C equals, let's do C equals 3. I want you to watch the graph and tell me what's happening. Well, I can't get right to 3, but I went to pi. So what happened to the graph? As I moved the slider and I made C larger, you can see it's being added in here, right? Because I moved it to the right, so it's adding pi. But what happened to the graph as I moved the slider to the right? If you're not sure, let's watch it again. I'm going to put it back. Here it is. And now again, I'm going to move it to the right, move my slider to the right, so I'm adding pi. Okay, so what happened? Well, as I added pi, I moved my slider to the right, so I added pi. It looked like the graph moved to the left, and that's exactly what happened. So just like you have seen with parabolas when we graph those, and with cubics when we graph those, the number that's inside the parentheses ends up having the opposite effect that you would think. When we add something, it ends up moving it to the left. And when we subtract something, well, let's see what happens. So here's back where we started. Now I'm going to go negative. Now I'm going to move my slider to the, I'm going to subtract. And you can see as I keep subtracting, my graph keeps moving to the right. And you can see the subtraction in here in the equation. So when I subtract 5.76, it moves that many units to the right. Okay, let's put that back. And so let's add in what we've learned so far. Actually, let's just keep going. We'll add it all in at the end. All right. Hold on. Let me go back to our graph. Okay, here we are. So that's D. We saw that D moved it up or down, and C moved it left or right. I'm going to skip B for a moment. Actually, no, let's do B. All right, so remember we talked about period length, and period is where it does a complete cycle through all of its values. So if we start at 0, the cycle is complete. We've gone through all of the values at by the time we get to 2 pi. We've gone up to the max, dropped down to the minimum, and then back up by the time we get to 2 pi. So what happens if we change b? Well, I'm going to increase b, and I want you to watch what happens to my graph. So what happened? Well, it almost looks like it's a spring and it's getting squished together, right? So the word for this is compression. We saw some compression happen to our wavelength. Now let's look at the period. So we start at 0, 0. We hit the maximum right about here. Then we go down and hit the minimum. And by the time we get to pi over 2, which is 90 degrees, we've completed a full cycle. So the period of this graph is pi over 2. So not only does B change the compression in terms of what the graph is going to look like, but B also has a huge effect on the period for the graph. So again, when I go back to 1, which is, nothing's done to it, no transformations, you can see that the period is 2 pi. When I change it to, let's say, 2, now what's my period? Well, I go up and then back down and then come up at pi. So I finish a full cycle by the time I get to pi. What about when I make it 3? Well, now it looks like I go up and come back down and come back up, and I'm not exactly sure what this value is. I could find it, but it's larger than pi over 2 and smaller than pi. And then when I get to 4, now I've completed a full cycle by the time I get to pi over 2. So B changes the period for the function, and it also changes the appearance in terms of making it more compressed. Now what happens when it's negative? Well, let's go to I want you to stare at positive 4. See what it does? It goes up, down, and then it's done by the time I get to pi over 2. Now I'm going to put it on negative 4, and I want you to tell me the difference. Okay, so now the difference here is that, remember, we went up and down and back up to get to pi over 2. Now we're going down first, right? But has the period length changed at all? It hasn't. It still completes a full cycle by the time it gets to pi over 2. So the period length has not changed. But what has changed is the fact that the points now go down first and then come back up, whereas before we saw it go up and then down. All right, so now I'm going to put B back. So B changes the compression, which changes the period length. And if it's negative, which I don't know that we're going to look at any that have a negative B, but just in case. So now let's look at A. Now A is at 1 right now. And notice our highest value is 1, and our lowest value is negative 1. So what happens if I change, and actually I'm going to move the midline up just a bit to 1. So now my highest value is 2, and my lowest value is 0, right? I go from 2 to 0 in my wavelength, and my midline is at 1. What happens when I change A to 2? So now my highest value is 3, and my lowest value is negative 1. Can you figure out what's happening here? I mean, if you watched the graph as I changed the slider, you probably saw that the peaks got higher and the valleys got lower. Okay, let me do it again. There's 1, there's 2. So the distance from the peak to the midline is 2. The distance from the valley to the midline is 2. That's what A represents. It represents the distance from the peak to the midline or from the midline to the valley, because those distances are the same. And here's where it shows up in the equation. Oh, I didn't point that out for B. So for B, this is the number that would change. The compression is the number that's being multiplied by X. Okay? All right, so now let's put this, oh, what happens if A is negative? All right, so here's positive 2. Let's see what happens if I go to negative 2. So back to normal size, 0, negative 2. So now we see kind of the same thing we would expect to see if you make the number in front of a quadratic negative or in front of a cubic negative. It flips it, right? We call that a horizontal flip because we're flipping about a horizontal line. So instead of going up and then coming back down, since my A is negative, I go down first and then back up. And you will see equations that have a negative value for A. So now let's put it all together. And that brings us here. So let's fill them in one at a time. Let's start with D because that's what we did when we looked at the graph. We started with D, and D is where we get this up or down shift. So if we're adding 3, it would go 3 up. Our midline would. Let me write that, midline. The midline is what's moving up or down, and that's in the center of the graph, right in between the peaks and valleys. So this parameter will move the midline up or down. C, we saw, moves it right or left. But what we're going to find out is that it's more than just C, because remember that C moves it right and left, but B also has some shifting going on because it compresses it. So we're going to use C and B together to figure out the right or left, which is called a phase shift. So we're going to use C and B together to figure out how far it's moving to the left or to the right. Then B by itself gives us the compression of the wave, and it also tells us the length of the period by using this formula. 2 pi over B will tell us the length of the period. And then finally, A, this parameter right here, will give us the amplitude, which is the distance between the midline and the peak, or the midline and the valley. And that's why it's an absolute value, because we're just looking at distance. But if A is negative, remember that's when we see a flip in the graph, where if it's supposed to go up first, it'll go down first, and vice versa.